Welcome to the 15th lecture on computational mathematics with SageMath. In the last lecture, we started learning SageMath and basically we explored integers. We looked at various methods that can be applied to an integer. Now, let us explore more things in SageMath. So, let me start SageMath notebook. Let me double click this icon. So, it will start SageMath server and it will open a Jupyter notebook. Let me go to the directory in which I have all the files. So, for example, this is the file we created last time, computational mathematics with SageMath lecture 3.1. So, if I click on this, it will open the file which we created in the last lecture. I just added the heading. So, let me just copy this and let me create another notebook. So, how do I do that? I will go to new and click on SageMath 9.1. This is the, again you can see here, untitled notebook. So, let me give the name computational mathematics with SageMath underscore lecture 3 -2, and then it will create a file name with default extension .ipynb. Okay. Now, in so let me create a heading for this also. So, I can convert this into markdown and let me just paste what I copied from previous lecture. This was lecture 14, now I will call lecture 15. Okay. So, and let us explore how to solve various objects in SageMath. So, let us explore solve function. So, solve function is very useful function in SageMath which can solve one equation, it can solve system of linear equation, it can solve inequalities, it can solve non-linear system of equations. All these things can be done. So, first let us let me write a subtitle. So, we want to, let us say, explore solve function, solve in SageMath. So, that is the subheading I am giving. Okay. So, first let us take a help on solve. So, I can say solve and let me put double question mark. In the last lecture I explained what is meaning of double question mark and single question mark. So, this will open a detailed help document along with source code. So, let us look at what it does. So, this is what you see here. Let me make it slightly bigger. Let me also, so this is the help document on solve and it tells you what is it. It says algebraically solves an equation or system of equations over complex numbers, and for detail for given variables it can also solve inequalities and system of inequalities. All these things can be done, and of course it gives you several examples. So, any of this example you can copy and paste it in Sage worksheet. So, let me go to the worksheet. So, let us see, suppose we want to first define a function. So, the simplest way of defining a function, let us say y is equal to f of x in this is declare f of x is equal to, so to begin with let us say it is x square plus x minus 2, that is the function. So, unlike Python, here you can use for power you can use caret symbol, or you could have used double star, both are same. So, let me just say x to the power 2 plus x minus 2. Now, this is very simple way of defining a function. You could have also defined a function as we did in Python using def keyword. I can ask it to for example show what is f of x. This will show you f of x in pretty print format. This actually is rendered by LaTeX package. In fact, one can generate LaTeX code of this. If I say LaTeX f of x, this will be LaTeX code. So, in case you are aware about LaTeX package, you would know what it is, what it does. You can copy paste this in this notebook. For example, I can just say control C of this, and let us say next cell I will convert into markdown, and if I say $, and paste this LaTeX code, and then $, closed, I can say f of x is equal to, and then if I run this, you will see that it has written this, it has given you LaTeX output f x equal to x square plus x plus minus 2. So, this is what we are dealing with. Okay. Now, once we have created this function, I can evaluate f of x, f at any point, let us say at f at 2 or f at minus pi. So, and so when I say evaluate f at pi, it gives me the value in pi itself. If I want the numerical value, by now you already know, we can say dot n, and it will give me the numerical values. Yeah, so that's the numerical values. Okay. So, now let us see how we can solve. So, we want to solve this f x equal to 0. We want to find x for which f x equal to 0. So, how do we make use of it? We can simply say solve, and in the bracket f x double equal to 0, because it is an equation and with respect to variable x. So, it will tell me what are the roots. Yeah, so the roots are 1 and minus 2. So, it has given the roots as a list which has 2 elements, x equal to this and x equal to this. You could also say an option. For example, if you want to print these roots as a dictionary, there is an option called solution and underscore dict is equal to true, capital TRUE, then the solution will be a list of dictionaries. So, this is a list of 2 dictionaries. First dictionary says that x1 and second is x is minus 2. So, this is very nice features. In fact, one of the reason why I introduced dictionary while we were learning Python, so that this kind of thing we can very easily explore, and especially if you have lots of roots or solutions etc., and you want to play with those solutions, you want to make use of those solutions, it is much more convenient to get them as a dictionary, so that further calculations will become easier. Okay. You could also find, so here again we have created f. Let me say what is type of f. I do not know what it will give. It says that it is a, again it gives me expressions. So, this is a expression class, right, and you can apply tab on this also, a dot tab, f dot tab. If you apply, there will be again several options which you can explore. So, for example, one of the options just now I saw is for example coefficients. Let us see. So, coefficients, yes. So, if I click on coefficients, it will tell me what are the coefficients of x, x square and things like that, right. If I want to find roots, I can say f dot roots, f dot roots, and it will give me the roots. So, it has 2 roots, 1 and minus 2, and this gives me the actually multiplicity. This gives me multiplicity, right. So, this f dot roots, this finds roots of a polynomial including complex roots. So, for example, if I say let us say I have x square plus x plus 1 and equal to 0, and or let me just say this and then say roots, it should find the roots, complex roots. These are complex roots, right. So, you can see here this solve function not only can solve in real over real fields, but also over complex fields. Right. Now, suppose you want to for example solve ax square plus bx plus c for a, b, c arbitrary. So, how do we do that? A, b, c we have to declare as a variable. So, by default in Sage x is thought of as a variable. For example, we declare the function f of x, we did not declare x as a variable. By default it thinks of x as a variable, but any other thing when you want to declare as a when you want to use as a variable, you have to declare. So, how do I declare? I will say variable and the bracket a comma b comma c, that is and then I want to say solve for example a star x square plus b star x plus c equal to 0 for x, then it will show you the first root is minus half into b plus square root b square minus 4 ac upon a, and the second root is minus half into b minus square root b square minus 4 ac upon 2a. So, let us store this in solution SOL, and if I ask it to show solution SOL, then it will print the solution in nice pretty print format, right. Okay. You could have also said that display this as a dictionary. So, if I say solution, so I am just typing keyword SOL and pressing tab, then already it gives me the options, and then choose the appropriate option, and this is true. So, now if I ask it to see what is solution, it gives you as a dictionary. So, this dictionary option is very useful. Later on also we will make use of this. You can also solve system of linear equations using solve function. So, for example, let us say I want to solve two equations, let us say x plus y equal to 6 and x minus y equal to 4 with respect to x and y. How do I do that? So, first we need to declare y as a variable. X is already a variable, but y we need to declare. But it is also a good idea to declare both x and y as a variable, because it is possible that you might have used x as some you might have stored some value in the variable x. In that case, there it may create problems. So, let me create x and y as variables, and now we will say solve. So, you need to give the two equations as a list. So, first equation is x plus y equal to 6 and second equation is x minus y equal to 4, and you want to solve with respect to x and y. So, in the bracket you can write x and y, you can write this without bracket also. So, that is the solution, x equal to 5 and y equal to 1. Again here you could have said solution dictionary equal to true. So, I can say solution dictionary is equal to true, then it will give you solution as a dictionary, and you can extend this to two equations in three equations, 4 equations, in as many variables as you want. And if you for example, if the system has multiple solutions, it will print the solution in terms of variable. So, if, for example, if I have said solve, let us say only one equation with respect to x and y, this is let us say 5, then it will print the solution in terms of variable r1. r1 can take any value. So, it has infinitely many solutions. If I want to find a particular solution, one can give value of r1, some particular value of r1, and then find. Okay. You could also solve system of non-linear equations using the same solve function. So, if I say let us say I want to find intersection of, let us say circle x square plus y square equal to 4 and hyperbola x into y equal to 2. So, if you imagine geometrically, it should have 4 solutions. So, let us see what we get. So, if I say again, let us declare x and y as a variable. You do not need to declare again and again, but it is a good practice actually, right. So, when I say solve, and the first equation is x square plus y square double equal to 4, and the second equation is x into y double equal to 2, and we want to solve with respect to variable x and y, then it gives you 2 solutions, only 2 solutions. If I say x into y equal to 1, then it has 4 solutions, right. So, or let me say x square plus y square equal to 1 and x into y is equal to, let us say, 1 by 4, then also it has 4 solutions. And again we could have used, we could have used this as a solution we can display in terms of dictionary. So, let me say solution dictionary is equal to true, right. So, these are the solutions. Now, suppose if I store this into S, so S is a, if I ask it to show what is S, these are the values of S, right. And so, there are 4 solutions. Each of these solution, if I want to kind of extract, it is quite easy. So, you can see here it is a list of dictionary. So, this is S of 0, it is the first solution. Now, you can run a loop over this solution set. So, I can say for, let us say, S, or let us say solution. So, S L n in S print S L n, this it will print all the solutions. Now, this is each one of it is a dictionary. So, I can even say S L n solution the value of x. So, let me ask it to print yeah. So, this is the first solution. So, for each one it is printing S L n x, and let us say this is the first solution, this is the second solution. So, it gives you a list. So, I can make a list. So, this is how you can extract these solutions. Okay, fine. So, this is the advantage of using this option called solution dictionary, so that it becomes easier for you to extract. And you can also solve inequalities using solve function. So, for example, let us say I say solve, and let me write inequality, say x square minus 2x minus 1 greater than 8, and you want to solve this for x. So, it gives you the solution of this inequality, or you can have list of inequalities, so that will also work. So, you can see here this solve function is very useful, which can solve one equation in one variable. It can solve system of linear equations, system of non-linear equations. It can also solve inequalities. So, it is quite useful. So, if you want to, for example, in between give some say subheading, you can do that. So, how do I do that? For example, here we have solved system of inequalities, system of non-linear equations. So, if I want, after this I can insert one cell and convert this into markdown, and then you can say solving a system of non-linear equations. Similarly, you can do it with other things, right. So, it is quite convenient to use this solve function. Now, let us look at, suppose you want to declare, say, function of 2 variables. So, the way to do is, first you need to declare x and y as a variable, and then let us just write g x y is equal to x square plus 2 x y minus 3 y plus exponential of minus x square minus y square. And again, whatever methods that you want to apply on g, all these things will be available using g dot and tab. Okay. So, you can go through this list and then explore these functions, right. So, this of course, we will come to this kind of functions when we explore calculus. Okay. Now, another thing I just wanted to tell you, last time I told you if you go to SageMath website, it provides you lot of documentations, but when you install Sage, this also has some inbuilt document. One help document is when we take help on a particular function or particular method using help or using question mark or double question mark. But if you click on this help, you can look at Sage documentation. If you click on Sage documentation, so this is actually, if you look at, notice this is not going to the internet, it is from the local host itself. So you can go through this tutorial, the thematic tutorial, there is a PREP tutorial, you can click on any of these things and then explore. So for example, there is a installation guide, developers guide, and a tour of Sage. So if I click on tour of Sage, this will give you how to get started with Sage with various things, including the plotting and other things, etc. Or you can go to, for example, again help and look at for example Sage thematic tutorial, or let us say Sage tutorial, and then you can just look at each one of these. You can, for example, if I say click on something to do with, let us say linear algebra, click on linear algebra, it will tell you some of the basic things in linear algebra, and you can copy paste any of this command, right. You can, if you go to, for example, help and go to Sage reference, then it will tell you the reference manual for various things. So for example, even if I say reference manual for coding theory, it will tell you many things about coding theory. So you can explore whatever is of your interest, and definitely when we start learning each of these concept, we can explore this further. Okay. So at the end, let me also leave you with some exercises. So let me delete all these cells. I think the previous one also got deleted. So let me go to this and undo the deleted cell. Yeah, this is what we explored, right. So let me convert this into markdown. So they are very simple exercises, like for example, find the roots of this cubic with respect to x, solve system of non-linear equations, this, define 3 linear equations in 3 variables x, y, z, and then solve them, and find out how many solutions does these 2 equations in 3 variables have, and find at least 4 different solutions. So these are few very simple exercises. So we will look at more on SageMath in the next lecture, especially how to plot graphs of various 2-dimensional and 3-dimensional objects, that we will look at next. Thank you very much.